We have the function y, or f of x, equals 1 over x squared minus 9. What are the non-permissible values of this rational expression? So it's a good thing to factor. Let's factor the denominator. We have x times x is x squared, and notice we have difference of squares, so we write x plus 3 and x minus 3 to be the factored form. And in math, there's a big rule for what we can't do. Non-permissible means what you cannot do, and the bottom cannot equal to 0. So when we say the factor is x plus 3, the factor does not equals to 0. That's the domain. But when talking about what are the actual non-permissible values, we don't say it in the negative. We say it in the affirmative. X plus 3 equals 0 causes a problem. This here, when we subtract 3 from both sides, we get x equals negative 3. This is a non-permissible value, NPV. Because when x equals negative 3, negative 3 plus 3 is 0, and 0 times anything is 0, and we have a division by 0 error, which is not allowed. So non-permissible values are in the affirmative, the equal sign, whereas the domain is in the negative, we use the not equal to sign. So focusing on the other factor, x minus 3, we write x minus 3 equals 0 to find the NPV. Throwing the negative 3 over, we have x equals 3 is another NPV, non-permissible value. So these are the non-permissible values, x equals plus minus 3. Whereas the domain is very similar to the NPVs. You just copy the answer, but change the equal sign to not equals to plus minus 3. Let's solve this rational function. To solve, we're essentially finding the x-intercepts. So we're setting y, or f of x, equals to 0. 0 equals x over 1 minus 3x. And when we multiply both sides by the denominator, this denominator disappears. And multiplying the left side by the denominator, we have 0 times 1 minus 3x. And anything times 0 remains 0. So we have the numerator as 0 equals x, and that's our solution. Now, when we have a polynomial function, usually the domain is all real numbers. Everything is okay. So everything is okay except for when we break the rules. And the rule here for rational functions is when we divide by 0. So what we're going to say is the denominator, 1 minus 3x, does not equal to 0. Throwing negative 3x to the right, we have 3x does not equal to 1. And dividing both sides by 3, we have x does not equal to 1/3 as the domain. And this implies that every other possible value of x is okay. We solve this rational expression by setting f of x, y, equals 0. We have the numerator 2x plus 1, x minus 2, and we multiply both sides by the denominator, so this denominator disappears, leaving only this part here. Anything times 0 is just 0. What times what is 0? We have 2x plus 1 equals 0, or x minus 2 equals 0. 2x equals negative 1. Dividing both sides by 2, we have x equals negative 1/2. Here, we have x equals 2. These are the solutions. These are also the x-intercepts, or the roots. We now graph f of x on Desmos. Notice how there is no vertical asymptote. To find vertical asymptotes, we set the denominator x squared plus 1 equals 0. X squared equals negative 1. And we can't take the square root of both sides, because when we do, we have the square root of a negative number, which is not allowed in math. So therefore, because we cannot actually set the denominator equal to 0 and get a real solution, there are no vertical asymptotes whatsoever. Thus, all possible x values are permissible. So x belongs to real numbers.